In this lecture series, we're going to be learning about conditional statements. By the end of this series, you should understand that conditional statements are able to decide between alternatives in an algorithm. You should know how to write algorithms using conditional statements, learn how Boolean expressions are used to build conditional statements in Python, and be able to trace through programs involving conditional statements. Before we get into the conditional statement syntax for Python, let's review some information about Boolean expressions. You previously learned to write Boolean expressions to model logical conditions. We can use a Boolean expression in software to ask a question and assess conditions in our software. We use the same kind of logic to evaluate conditions in our everyday life. Suppose that we have the following information. Jane is a student and she's a sophomore and is 25. Kristen is a freshman and is 18, and Sally is a sophomore who's 21. Consider each of the following Boolean expressions and determine whether it would evaluate to be true or false. Notice that the statement might be true for more than one person, or it might not be true for anyone. Take a couple of minutes, pause the video, and then come back and check your answers. So if we were evaluating the expression person is a sophomore using these three different students, then the statement would be true if we evaluated it with Jane, it would be false if we evaluated it with Kristen, and it would be true if If we evaluated this expression, person is a sophomore, using our three students, it would be true for Jane because she's a sophomore, false for Kristen because she's not a sophomore, false for Kristen because she's not a sophomore, and true for Sally, who is a sophomore. If we evaluated the second condition, person is a freshman and person's age is greater than or equal to 20, it would only be true for the students that satisfy both of these two conditions. They would have to be a freshman and also be greater than 20 years of age. So it would be true for Jane, she's a sophomore and is older than 20. It would be false for Kristen because she's a freshman. So if we evaluated this expression, person is a freshman and person's age is greater than or equal to 20, the result would only be true if both conditions were met. So if the person is a freshman and also has an age greater than or equal to 20, then the whole condition would be true. If either part or both parts were false, then the overall expression would be false. So if we evaluated the expression with Jane, it would be false because Jane is not a freshman. If we evaluated it with Kristen, it would be false because Kristen, while she's a freshman, she's not older than 20. And it would be false, and it would be false for Sally because she is not a freshman. So of the three students we know about, none of them would make this second condition true. Let's look at the third example. The person's a sophomore and their age is less than 20. If we evaluated that with Jane, she would make the first part of the expression true because she is a sophomore, but the second part of the expression would be false. If we evaluated this expression with Jane, it would be true. Jane is a sophomore, and because the or condition only requires one of the two expressions to be true for the overall expression to be true, she meets the criteria. She's a sophomore, and it doesn't matter that she's not less than 20 years of age. Kristen would also make the expression true. She's not a sophomore, so the first sub-expression would be false, but she is younger than 20, so the second sub-expression would be true. And again, with an or operation, if either or both of the sub-expressions is true, then the overall expression is true. Finally, if we evaluated it with Sally, it would be true because she's a sophomore, so she satisfies the first part of the expression. Let's move on to the fourth example. We're looking for not a person is a sophomore, and the person's age is exactly 18. Remember that this expression is going to be false if the inside expression, the person's a sophomore and exactly 18, is true. So if we evaluate this with Jane, Jane is a sophomore, but she's not equal to 18 years of age. So the inside of the expression is going to be false. And then when we apply the not operation, it's going to take the inverse value and return true for the overall expression. If we evaluate it with Kristen, Kristen's not a sophomore. So we know that the entire inside sub-expression is false. She is 18, but because both conditions have to be true for this inner compound conditional to be true, then we won't meet both criteria. So the inside expression is going to be false. And then when we take the inverse of that with the not operation on the outside, it will be true. And finally, Sally's a sophomore and she is exactly 21. When we evaluate that, she is a sophomore, but she's not 18. So the inside sub-expression is false. And when we take the not operation of that false sub-expression result, then we're going to get the inverse value, which is true. So absolutely everyone made this example down here true. It's kind of like saying if none of the people are and the result of this sub-expression is kind of like saying, suppose, and the result of this expression is kind of like saying, give me a true answer if the person is not a sophomore or if the person's age is not equal to 18. And since Jane's age is not equal to 18, she returns true. Since Kristen is not a sophomore, she returns true. And since Sally's not 18, she returns true. Let's look at the final example, not of a person is a sophomore or the person's age is 18. This is kind of like saying, give me a true answer if the person's not a sophomore and the person's age is not equal to 18. Let's look at the inner sub-expression for Jane. So Jane is a sophomore. She's not 18. The inner sub-expression is going to be true because she meets one of the criteria. She is a sophomore. And then taking the inverse of that to get the final answer, we'll get a false. If we evaluate this same expression with Kristen, Kristen's not a sophomore, so this first part's false. Second part of the inner sub-expression is true. She is 18. So the whole inner sub-expression is going to be true. And then when we take the inverse of that, the answer will be false. Finally, if we evaluate this with Sally, Sally is a sophomore, that part is true. She's not 18, that part's false. However, she meets at least one of these two criteria for the inner compound conditional. That means the inner conditional is going to return a true value. And then when we take the not of that to get the inverse value, we'll get a false. So this gave a false result for absolutely everybody in our student pool. So remember, looking at these examples, remember that when we're writing these kind of conditions in Python, it's really evaluating the same kind of logic you apply in everyday life. Whenever you are applying an AND operation, the result is only valid if both of the items that you're considering are valid. If you're considering OR, you're typically, if you're evaluating an OR expression, you're typically saying if one or the other or both is true, then the overall expression is true. And the same thing's true in computer science. And then finally, if you're saying not, it's like taking the inverse operation, always gives you the opposite of the operand's value. Boolean expressions might be interesting on their own, but they really become useful once we learn about conditional statements. These are statements that are used to make decisions to do something in our program.